So now that we know a little bit about basic trigonometry, our goal is to start finding the lengths of the sides of a triangle and the angles of a triangle that are missing when you're given certain information. So I might be given a triangle where I'm given two of the sides. Maybe this side is 5 and this side is 10, and this angle is 92 degrees. Then I want to be able to figure out how I can find the other side, the one missing side, the other two missing angles. So to do this, we're going to use a couple of what we call trig logs. The first one, the law of sine, and the second one we'll learn in the next section is the law of cosine. Now the law of sine is very, very simple when you look at it. And the law of sine just says in any triangle, so it doesn't have to be a right triangle, it could be any triangle you want, with angles A, B, and C and sides little a, little b, little c, which are opposite their angles. So if I think about what this is going to look like, I'm going to have a triangle. I'll just draw this generic triangle here. So we have big A, big B, big C for our angles. So the side across from A is little a, the side across from angle B is little b, and the side across from angle C is little c. Now there's not really an opposite or adjacent or hypotenuse necessarily, because these aren't always right triangles. These are just any triangle. But if you have this triangle, then the sine of the angle divided by its side is the same for all three sides and all three angles. So the sine of A equals the sine of B over B, the sine of C over C. Now proof of this is actually very simple. So let's go ahead and just draw some regular triangle. And again, I'll just label it A, B, and C. Little a, little b, little c. Now how this works, to prove this true, is I am just going to draw a perpendicular line from B straight down. And what you have here is we now have two triangles. I have a triangle on the left and a triangle on the right. So they are both related because they both share this common side. This common side we'll call H. Well, now if I look at these two triangles, I can say the sine of angle A is the opposite over the hypotenuse. And now I can use the SOHCAHTOA because the red and the black triangles are right triangles. I also know the sine of angle C is equal to H over A. So using the black triangle, opposite over adjacent is H over A. So now how we can solve this is we could solve both of these for H. So in this case, H equals C sine A. And in this case down here, H equals A sine C. And so I can just set those equal. So I have C sine A equals A sine C. And I'm going to divide both sides by AC. And the benefit of that is, in this one the C will cancel out, and in this one the A will cancel out. So we end up with sine A over A equals sine C over C. Now, we didn't have anything involving B. You certainly could do the same thing to prove that sine B over B is the same, because I didn't really label these letters anyway in particular, so I could switch the A with a B. So that's why this is equal to sine B over B. So that's why this is true, but this relationship is really, really nice to use, but you have to be given some kind of information to use it. So if we're going to do this, we have to have two pieces of information. The first way we can do this is if we have two sides and the non-included angle. Now what we mean by non-included angle is I have two sides. So let's say I have a triangle. Let's say I know this side. Let's call it A. And I know this side, which is B. And I know this angle. I know it's big A. So the included angle would be the angle in between the two sides. If I don't know that one, but I know the non-included angle, I could use the law of sines. This one sometimes is tricky. We sometimes refer to this as the SSA case. And this one has several different subcases. This one can be somewhat problematic. So we'll talk about that one in detail. But you can use the law of sines to solve these triangles. The other one, and much more simple one, is if you have two angles and one side. So if you have any two angles and any one side, you can use the law of sines to find all the other information, and we call this ASA. So really the letters just represent what information you're given in the triangle to try to find all the other parts of that triangle. So let's look at this first case, which is side angle, where you have two angles and a side, and the side doesn't necessarily have to be in between the two. It can be a side not in between the two angles, but as long as you have two angles on one side, you can use the law of sines. Now in this first problem, you notice for both these I have both angles. Well, the simplest thing is to always find the other angle first. So all angles in a triangle add up to 180 degrees. So angle C, the missing angle here, will be 180 minus 108 minus 23. So that is going to give me 49 degrees. Now in any of these calculations, if the video goes too fast, you need to pause it. Feel free to do so, because I will run through some of these calculations once we get the ratios set up relatively quickly. So now I need to find two sides here. So in this case, I need to find side A, and little b. So if I set up my law of sines, remember the sine of angle A over little a equals the sine of angle B over little b equals the sine of angle C over little c. Now generally we don't use all three at once. We typically use only two at once, two of these three ratios. But I have to have one of them that has everything filled out. That's an important thing for both of these. And in this case, you can see I know what angle C is, and I know what little c is. So I know both of the things that go in this ratio. So I will definitely use the sine C over C, and then I'll use one of the others. It doesn't matter. I'll start by finding side A. So we know sine of A. Well, A, I do know what angle A is. It's 23 degrees over little a, because I don't know what that is, equals sine of C, but C is 49 degrees over little c, which is 7.7. Now, sine of 23, sine of 49, those are both numbers. 7.7 is obviously a number, so you're really just trying to solve a proportion with numbers in one variable. Easiest way to do this is to just cross multiply. So if I cross multiply, I'll get A times sine 49 equals 7.7 times sine 23. And then since sine 49 is a number, I'm just going to divide both sides by sine 49. So I get A equals 7.7 sine 23 over sine 49. So when I put this in the calculator, and I highly suggest you put this expression in the calculator, I'm getting 3.99, and that would be centimeters. So this is 3.99 centimeters. Very important you try to put this in and make sure that your calculator is in degree mode. So if you're unsure how to do that, see me. We can make sure your calculator is in degree mode, because recall there is radian measure of angles that we talked about in a previous section. We want to make sure our calculator is not reading this as 23 radians for a degree, but 23 degrees. So now I have two sides and all the angles, so now I'm going to basically just find the last side, and I'm going to do it the same way. I'm going to use it the same way I did up here, but instead of using the B's and the C's and the A's, I'll use the B's and the C's. So when I set it up, it'll be very similar. So it's going to be sine of B this time, which is 108, divided by little b, equals sine of C over little c. Now, I certainly could have used A, because I know both little a and big A now this time, but I'm just going to go ahead and stick with what I did before. So when I solve this, you can go ahead and work this out. You should get B equals 7.7 sine 108 divided by sine 49. Just cross multiplying and then dividing by sine 49 like we did above. And in this case, this one's going to be equal to 9.7 centimeters. Now, just a real quick check to make sure that everything worked out. One thing you should know from geometry, remember the longest side should be across from the biggest angle. The shortest side should be across from the smallest angle. And the middle length side should be across from the middle sized angle, which is what we have here. That's always a quick way to check and make sure that we've got reasonable answers for our triangle. All right, let's look at the second triangle here. Same idea. We have two angles and a side, so really the same thing. I would first start by trying to find my other angle. So my other angle in this case is angle B. So the measure of angle B is going to be 180 minus 131 minus 11, which is going to be 38 degrees. And then I'll just start setting up my ratios. Now the one thing I know in this case is I need little a, I need little b, but I have little c and I have angle C. So that's the one I'm going to use. So I'll find, for fun, I'll find little a first. So I know the sine of angle A over its side A equals the sine of angle C over its side length little c. I'll cross multiply. Same idea. These all work very similar once you get them set up. A sine 11 equals 0.65 sine 131. We'll divide both sides by sine 11. And again, sine 11 is just a number. So we get 0.65 sine 131 divided by sine 11. And so if I work that out in the calculator, it gives me about 2.6. And that'd be 2.6 miles because our original unit was in miles as well. So side A is 2.6 miles. So now we have to find side B, which will be very similar. We'll set it up the same way, but instead of using the A angle, we'll use the B angle. So we have sine of angle B. And remember, angle B we found to be 38. I can write that in my triangle just so I remember. Sine of 38 over little b equals sine of angle C over little c. I'll cross multiply again. So I'm going to end up with b equals 0.65 sine 38 divided by sine 11. So if I work that out, b is going to be 2.1, and again, this would be miles. We want to check in our triangle to make sure that everything matches up. Nothing kind of the biggest angles cross from the biggest side, small side, etc., etc. Everything seems to work. So these are my solutions. So these angle side angle ones, fairly straightforward. The side angle ones will be a little more challenging and have some different cases for us to deal with.